Okay, today is our last lesson on measurement. And so as we begin today, measurement has been really about a couple of different things, but the main things have been area, surface area, and volume, right? So that's what we spend a lot of our time talking about. And then we've also spoken about 3D shapes. So this is a rectangular or square prism. This would be a triangular prism. So those we have seen before in earlier grades. This is called a cylinder. So you need to be aware of the pieces that go into that. Then this is called a pyramid, and the pyramid can have different types of bases. And then this is called a cone, and this is called a this is called a sphere. This is called a sphere. If it was cut in half, then it would be a hemisphere. So these are the three shapes that we've been dealing with over the last while. Give me a thumbs up if you have been introduced to these shapes and you feel sort of comfortable interacting with them. So the other three have been newish, but we're getting there. Okay. Now we're going to get there. There's some things that stand out in the, so maybe I should just go over that. If I look at the cylinder is based on a circle, but if I have to do the surface area, it's actually two circles and a rectangle. And if I look at the shape, this thing along the top is actually the one length of the rectangle, and this thing over here is the other length of the rectangle. So if we're finding the surface area of a cylinder, that is going to be there's going to be two parts. In fact, I'll even write it for you. It's 2 pi r squared because of each of these. And then it's going to be 2 pi r, or diameter times pi, which is the green bit, times the height. Or you could say this as 2 pi r times height. Give me a thumbs up if you remember that little bit tricky surface area formula for cylinder. You will be given this formula, but you just need to know how to recognize it. Okay, then if we look at the shapes over here, what's a little bit special about the pyramid is there's the height of the pyramid, which is like this thing over here. We'll call it big H. But there's also something called the slant height. We'll call that S. And this makes a right-angled triangle inside of the shape. And so it's important that we remember our friend Pythagoras can help us figure out the relationship. So say, for example, we had something like that being 3 and that being 10. We could use Pythagoras to help us figure out what this length is over here. And the same thing could be used over here with the cone. We have that as the height of the cone. We have this as the radius, and then this over here would be the slant height. So we spent quite a bit of time in the last lesson talking about these right-angled triangles that exist in these shapes. Give me a thumbs up if that has still stayed with you and you're remembering the work we did here. Now, for both of these shapes, the volume is just 1/3 times the area of the base. So I'll say A for area of base times the height of the height of the shape. And when I say height, I literally mean this thing, the red stick over here. When it gets to the surface area, it gets a bit more interesting. For this one over here, it's just going to be whatever the base is plus 4 times whatever the area of the triangles on the outside are. Whereas here, we're going to have pi r squared for the surface area of the bottom, but we're also going to have an extra bit called pi rs, which is going to take care of these pieces over here. And again, this will be given to you. I'll show you an exam now, but just going over them to start with. And then the last one we spoke about was the sphere. The sphere has a volume of 4/3 pi r cubed, and it has a surface area of I'll check it now. I think it's 2 pi r squared. Or is it 4? No, it's 4 pi r squared. But I'll check that. Let me just check that. I'm having a moment. Yeah, I'm pretty confident. Anyway, we'll check that later. Okay, so let's go to a question that resembles the last lesson. I want you to find me the volume of this shape over here. This is a combo shape. Maybe tell me, what are the two shapes that go into the volume of this shape? I want to see in the chat, what are the two shapes that go into making this shape? So there's the rectangular prism. Thank you, Naledi. That is fantastic. So just see if I can pull out the rectangular prism. I think it's just chilling over here. There is my rectangular prism. What else do we have? Pyramid with a square base. Yes. So here is my pyramid with a square base. Okay, you go ahead and find the volume for me. If you can give us some tips along the way, do that. But I'll give you a moment, and then when you're done, just say done in the chat. I will give you the formulas for the other shapes. So for rectangular prism, they would give you on the formula sheet, they give you that. And for the pyramid, they would say volume pyramid is 1/3 times area of base times height. So see if you can use that to figure out what the volume is. You are given these two things there. Let me just make sure I welcome everyone. Welcome to Akwande, to Alexa, welcome to the beginning, Asande, welcome to Bukle, Callan, Koketso, Livu, Machadiso, Mateo, Naledi, Njabulo, Nukobonga, Nawe, Reniwe, Sinako, Siamtanda, Tenda, Tandiwe, and Busile. It is awesome to see you here and see you working hard and going for it. So you can give me the answer in the chat if you've got it, or you can tell me if you're done. I'm going to start with the bit that I think is easiest, which is 30 times 30 times 15. So that takes care of, I think, all the stuff inside the blue one. But now I need to worry about the pyramid. So plus, but now I've got a problem because, well, I don't have a problem at the beginning. So I've got a third. Oh, actually, that's not too bad. A third. Now I'm going to say area of the base. Well, the area of the base is going to be 30 times 30, and the height they've given me, which is 20. So what is my total volume going to be? Plus a third times 30 times 30 times 20. Who has got an answer? I've got my answer, but I want you to share yours. I am getting 19,500, and that would be centimeters cubed. How did we get the area? So Sanako, if you look at this shape here, it says that it's a 30 by 30 centimeter shape. So you know that this is actually a square. And to find the area of a square, you just go 30 by 30. So that's where, and then here at the top, it's 30 by 30 by 15 for that. Yeah, let's go to Reniwe. Let me just open the queue. Reniwe, go ahead. What is your question?
Hi, sir. In
Hello.
terms of the formula, I was asking, for the pyramid, it says a third times A. What is A? And in terms of the formula of the volume of the rectangle, what is the, I don't know, it's a Q or E.
Okay, it's an L. Sorry. No, thank you for your question. My handwriting was being a bit dodgy. So let me show you what I mean here. So the first question is, what is the A? The A is the area of the base. So if you look at this pyramid here, this is the base of the pyramid, and it's a square. So in the formula, they often just say A, area of the base, because it doesn't have to be a square. It could be a bunch of stuff. So that's why there's an A, but what that A actually means is just, so I'll even match it for you. It's this part over here, okay? Now the 20, which is the height of the pyramid, is over here. And the third is part of the formula. Third times, and then this would be just be times the height. If I look over here, it says the prism, this is length times breadth times height. So that's why, let's say the length is 30, the breadth is 30, and the height is 15. So that's where that comes. And I get 19,500 centimeters cubed. Give me a thumbs up if that made sense to you. Fantastic. All right, well, next I want to find the surface area of this shape. Now, the surface area is different to the volume because it's how much wrapping paper would fit on the outside of this shape. So I want you to think about what would be covered by the other shapes and just give it a go. Start doing it. The formulas for let me just get rid of these formulas. So for a pyramid, the surface area is going to be the area of the base. So the area of the base plus 4 times whatever the area of the triangles is going to be. And then the surface area of a normal rectangular prism is just going to be, well, it can be a couple of things, but I quite like, well, yeah, that one actually you need to sort of just figure out as you go, but it's basically a whole bunch of rectangles. Okay, see if you can find me the surface area. So I'm going to say that this is basically this one, and it's matching friend at the back there. But let me take that back. And then on the side, I'm going to have 2 times 30 times 15 again, or 15 times 30. 15 times 30. Now, what is the other one going to be? Oh, there's one on the bottom, which is 30 times 30. So just think on the very bottom of the shape, there's a 30 times 30. And that's it. So there's 5 rectangles to handle the bottom part. But now I have to worry about the surface area of the pyramid. And the base is covered, but I've still got these 4 triangles that I need to add up. Can anybody help me with what I need to do first to sort of get the area of one of these triangles on the outside? Who has an idea for me? Some wisdom they could share. Sharing is caring. There's one key step. There's a familiar friend we have to call to help us. Who are you going to call? It's the slant height. Yes, Naledi, thank you. So, and Pythagoras. So we need to know this one over here. We know that that's that. What is the green one going to be? What is the green length going to be? Does anybody know what that's going to be? Well, since this has to be in the middle, and this is 30, this has to be 15. So now work out for me what that slant height is. Work out for me what that slant height is. So by Pythagoras, S is indeed, that would be 3, it would be 25. So we'll say 25 centimeters. So now, to figure out the area of these 4 triangles, I just go 4 times, and then I go a half. Now, what's the base of the triangle? The base of the triangle that I'm interested in is actually this one here. And so that is going to be times by 30. And then the height is this thing called the slant height that I need, which is 25. Give me my final answer for these 2 bits and pieces. I'm going to do it with you at the same time. So 2 times 15 times 30 plus 2 times 15 times 30 plus 30 times 30 plus 4 times 0.5 times 30 times 25. What do you get? Did I give it away? Oh, sorry, Boucle. I got a bit too excited. I get 4,200. Does anybody get 4,200 centimeters squared? Okay. So watch out, Naledi, because there's plus signs between. So there's a plus sign here, there's a plus sign here, and there's a plus sign there. Boucle, let's go to you. Hi, Boucle.
Hello, sir. I just have a question. My
Okay.
formula for the area of a rectangular prism is 2 times L times B plus in brackets 2L plus 2B times the height.
And again, so for the surface area of a prism, 2 times L plus B
times B.
plus 2 times?
Yeah, so it's 2 times L times B plus 2L plus 2B times height.
Oh, there we go. 2 times L times B plus 2 times?
L
Times?
plus B plus 2 times B.
So for some reason I'm missing it. So okay, here's the main thing, Boucle, is that when we deal with the shapes that are stacked together, we can't have 6 rectangles, we can only have 5. So that's why I have 2 for this, 2 for that, but then this last one doesn't get a 2. And the reason is that one of the rectangular faces is covered by the pyramid. It's like the box is, the base of the pyramid is sitting on the box, and so it can't be included in the surface area. Does that make sense?
Oh, okay, because I was wondering why are there 2? Why are we multiplying 15 times 30 twice?
Oh, that's because there's a square base. So if you imagine here's a 30, right? And here's a 15. And there's a matching one on that side. But there's also a 30 times 15 over here, and then a matching one on the other side there. So I could have said 4 times 15 times 30 if I wanted.
Okay.
Thank you for your question. It was a good one. Okay. Now, let us try and find the volume of this shape. So what 2 shapes are stuck together to make this shape? It's a cone and a hemisphere. Perfect. So if you think, I'll give you the formulas you need. 1/3 times the area of the base times the height is the formula for a cone. And the formula for the volume of a full sphere is 4/3 pi r cubed. Can you work out for me the volume of this shape over here? And if you're stuck, put your hand up and ask a question, just like Bukle was asking there, or put it in the chat. Did we do this one in the last lesson? Hands up if we did this one in the last lesson, everyone. I think I'm having an old person moment. Okay, moving on. Okay, let's go to a question from a past exam before we have our halftime break. Okay, so this is taken from a past exam paper. Notice how they give you a formula to help you. So it says a pyramid with a square base. Now, they've only given you the 16 here, but what you need to remember then is that they're secretly telling you that all of these are the same. P lies on the square base below. The volume is 640 centimeters cubed. Okay, question number 1. Show that the perpendicular height of the pyramid, AP, is 7.5 centimeters. So where is AP? It's here. Who can tell me how we are going to show that this is 7.5 centimeters? Any ideas? What can we work out first? So half of the 16 could be 8. So I think that could work quite well. Yep. What else can we use? Well, maybe, couldn't we use the volume of the pyramid we've got, the height? Ooh, I wonder, could we maybe use the 640? Oh, Callan is coming to the rescue here. Callan, let's slant height Sonaka. Okay, use the volume. Callan, I think you were thinking the same as me. What if I said 640 equals 1/3 times area times height? Now, the thing I want is this height. If only I knew what the A was. Could anybody tell me what the A is? So the A is not 16, but you're on the right trail, because remember, this is the area of the base. So the area of the base is going to be this space here. My coloring skills aren't so good. Does anybody know how I can get the area of the blue bit? I think it's just 16 times 16. So we'll get 640 is 1/3, 16 times 16 times height. And then I want you to take this whole thing and move it to the other side and see what you get for H. What do you get for H? So all you really need to do is go 640 divided by 1/3 times 16 squared. What are you getting? Well, Sunday, that makes me very happy, because that is the answer they were asking us to show. So we have now shown that this height over here is in fact 7.5 centimeters. Fantastic. Okay, now, the last question, which you're going to do for me, I'm going to keep quiet, or at least I'm going to try to, is you're going to find me the total surface area of this shape here. And I'm not going to tell you anything else. You are going to use that and while I get some water, and then we'll take a break after we finish this question. So think back to earlier in the lesson. How does surface area work? What do you need to get for surface area? I know the blue bit was just 16 times 16. Wait. Okay, what are we getting? Okay, so Narco, let's see if I agree with you. What I need to do is to find the slant height first. That was quite important. So let me find what AT is. It's going to be 7.5 squared plus 8 squared. So for AT, square 8 squared. So I get a bit of a messy one. I get, for AT, I get the square root of 481 over 2. So I'm going to use that, and there's 4 triangles, so 4 times a half times the base. Now the base is actually going to be 16, and then I'm going to get my messy 481 over 2. So now I've got to add all the stuff up. So 16 times 16 plus 4 times 0.5 times 16 times 481 over 2. And what are you guys getting? Why am I getting something a bit different? Let me try that again. 16 times 16 plus 4 times 0.5, so 4 times a half, times 16 times the fraction, which is 481 square rooted over 2. I get 606. So I get 606.91 centimeters squared. That is what I get. Sunday agrees with me, and so 606, yeah, okay. Perfect. And there'll be a little, if you did round that off, there'll be a little bit of a difference, but that's fine for now. Okay, everyone, give me a quick score out of 10. How are you feeling about measurement at the moment? 0 is like, there's no hope. 5 is like, okay, but I'm still improving. 10 is like, I've completely waxed this. How are you feeling about this topic at the moment? And again, there's many different types of people at different stages of their learning, so we'll get different values. I just want to get a feel for the group. Now remember, this is our 4th lesson on measurement, so you can go back and actually look at the build up to the previous lessons if you're finding this lesson very difficult at this stage. So I want to encourage those who are new that we have done 3 lessons before that, and we have a YouTube channel. And what I'm going to do now is just put the link actually for the grade 11 playlist for our YouTube channel, because I think sometimes when you first join, not all students know where to look for that. So let me just put that in the chat. And that, if you're really struggling with this topic, I would highly encourage you to go back and maybe watch the previous videos on like double speed, just to get a feel for the topic. Give me a thumbs up if you all can access the YouTube playlist and you know what I mean about re-watching parts of the lesson. Awesome, awesome. Okay, well, you know what time it is. It's break time. So what do we do on break time? We step away from our desks and we take a moment for ourselves. So please, everyone, step away from the desk, step away from the bed, step away from wherever you are right now, and join me in just taking a moment for yourself to unwind. It's rather hot today in Cape Town. Whoa, it's cooking. Okay, so we're going to take 3 deep breaths. Breathe in. Breathe out. Breathe in. Breathe in. Last deep breath. Okay, now we are going to next just shake our arms out a little bit so we get nice and loose. So shake out the arm, get it nice and loose so that you feel floppy. Shake out your legs. Shake out your legs. You want to feel nice and loose. Roll your shoulders a little bit. Roll them the opposite direction to what you were doing. And then you can even spin around a little bit with your arms, just gently. And this all just tells your body it can relax. Okay, so we've got oxygen, we've got relaxation. Now we want blood flow, and we are going to do jumping jacks, which are like this. And we are going to do 15 of those jumping jacks in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And just take 30 more seconds for yourself to just unwind before we continue with part 2 of our lesson. And if you feel so led, hit the emoticon. Let me know how you are feeling at this stage. All right, my heart is pumping, but it's a good pumping. It's not a scary pumping. I'm alive. It's pumping. Okay, let's go back to this old exam question. So it says you are given a cone with a perpendicular height of h centimeters and a radius of r and a slant height of 13. They give you these formulas. Show that the volume of a cone is given by this. Now this looks a bit scary. So we're going to have to get some help here around what to do. When they say the word show, what they mean is they say they don't want you to just write it down. They want you to show the pathway to getting there. But remember, over here, They told me a formula. So you need to get from here somehow to there using what's in the drawing. So can I have suggestions about where I would start? What would you do to start with the volume? Because clearly it's about the volume. Hey, remember, volume, volume. What would you start by doing? Any ideas? Calculate R. Yes, if you could calculate R, let's have a look. Well, I was thinking, okay, now they don't give you anything except the slant height. Okay, and I would totally say calculate R, but they don't seem to have it. So how about we just say 13 squared is equal to h squared plus r squared by Pythagoras, because there doesn't seem to be too much else. Can I have a thumbs up if you followed what I did there? So if you see there's a right angled triangle, there's the height, okay, there is the radius, and there is the slant height. So all I'm saying is that because of Pythagoras, that must be true. All right, so now what I want to do is, if I look at this, there's only pi's and h's here. Now I wonder if we can sub something in. It says the surface area of a cone is that. Okay, but they don't give us anything else. Well, let's take R. You see this R over here? If I say to you R squared is equal to h squared minus 13 squared, or let's say h squared minus 169. Are you guys and girls with me? Thumbs up if you can follow that. Because what I did was I just moved this to the other side, and then 13 squared is 169. Okay, I feel like I'm getting warmer now. Now, if I look at the volume thing, I have 1/3 pi, and then I have an r squared times the height. I somehow have to link the two things in blue to give me that thing over there. What would you do to link the things in blue? Can anyone see a link? So it would be, the question is, shouldn't it be just h? No, it's h squared. And if you think about it like this, it's almost like I just did this. 13 squared minus h squared is r squared. So it's like r squared is 169 minus h squared. Ooh, did I make a mistake? Hold on. Let me just do this bit again. Sorry, guys. I just realized I might have made a little mistake. So let's go back. So if I left this on this side, 13 squared minus h squared is r squared. So 169 minus h squared is r squared. Now, what I noticed is that there's an r squared here and there's an r squared there. I think that if I take this r squared and sub it in here, I'm going to be in business, because I saw there was a 169 already. So I go 1/3 pi, then I go 169 minus h squared, and then I have an h. Give me a thumbs up if you followed that. So I'm connecting. Okay, so if I lost you on that, I'm sorry. Don't worry though. It's a tricky one. I'm basically using this relationship, which is Pythagoras, making r squared the subject of the formula and putting it in there. And the reason I knew to do that is there was no r in this formula. If I look at it now, there's only h's. So I needed a way to relate h and r together. Okay, last step. How do we get this to work? Well, 1/3 can be written as over 3. So that's fine. The 169 and the h, so the pi and the h can come to the front. So I get that. And then the last bit is just going to be 169 pi h minus pi h cubed over 3. That's a properly difficult question, but it wasn't. The real key was to connect the two together. So we are getting a bit hard. So if I frightened a few people there, I do apologize. But it's good to see like the promised land as well. Like that's what we're aiming to get up to as we practice more things. Now that I've explained it, give me a score out of 10 for how much you feel like you understand that, how I explained that question. Give me a score out of 10 there. Was it a 2 or 4 or a 7? How are you feeling? Because that was a toughie. I'm not going to lie. That was a toughie. Now, the one thing I don't like with exams like this, I don't like when they put the hardest question first. The second one is much easier, but most people would have got such a fright with 8.1 that they wouldn't have looked at 8.2. So when I told, like when you do an exam paper, it's often important to realize that not all the questions are equal difficulty. Anyway, you'll see what I mean now. Find me the answer to 8.2. Determine the surface area, and remember you're given the formula over here. What is the total surface area of the cone? Can you work out the surface area of the cone? Why is it h squared? Are you talking about the over here, Machadiso? So in basically the Pythagoras theorem has this side squared plus that side squared is equal to that side squared. So the reason it's h squared comes from the Pythagoras. Does that help, Machadiso? Now, the formula for the surface area is pi r squared plus pi r s. Okay? So we now need to work out what is this going to be. Oh, and they tell me h is 12. Well, that's kind of helpful, because then I can just go, well, if h is 12 and this part is 13, you can work out the radius for me using Pythagoras. Can someone work out r for me and tell me how they get r? Oh, h cubed. Sorry, Machidi, so I understand what your question is now. The reason it became h cubed in the end is there was already an h in the formula. So in the volume, so you have your, yeah, so these are, everyone's working on surface area, but I'm just quickly answering Machidiso's question. In the volume formula, there is already, okay, an h. But then we go and put a 169 minus h squared, sorry, minus h squared in there already. And so that's why we get more h's. Yeah, that's why we get more h's in terms of this. Okay. So now, according to Pythagoras, the r is 5, in which case we get pi r squared, pi 5 squared, plus pi times 5. What is s? S is 13. So what is my final surface area going to be for this cone? So the biggest thing I'm noticing today with the exam questions is how they're interconnected. You have to understand how to connect the formulas together a little bit. Now, they won't all be this hard, I promise, but it's just good to, yeah. So 25 times pi plus pi times 5 times 13. So I get 90 pi, or as a decimal, I get 282.74, and that would be centimeters squared. Now that was much easier. So even if you have a question like this, always look at the second part if it's not an easy one like this, because you can get 3 out of 7 even without touching this one over here. Are there any questions or comments about this question? Anything you'd like me to go over before we can probably got time for one more question tonight? Okay. Well, then, why don't you find me the volume and the surface area of this shape? So find me the volume and surface area of this shape. What type of shape is this? This, to me, looks like a triangular prism. Yes, Callan agrees. So here's the triangle, and then it keeps going back. So it's a triangular prism. Work out the volume and the total surface area of this shape. I'll give you a hint. For the volume, you really want to start with this green triangle. That will help you. Okay, so let's see. Volume, I need the area of the triangle, so a half base times height gives me the triangle in front, but then I need to times it by 14 for how deep the triangle is going. So we go 0.5 times 18 times 15 times 14, and I get 1890 centimeters cubed. Anybody agree with me? So let me just go over why this is the case. So imagine if you want the volume of a triangular shape, you've got a front triangle like we've just got, and now you've just got more and more triangles behind themselves. That's why you need to multiply by the 14 to get the depth of the shape. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't. Okay. Now, next one is surface area. Now, surface area is where you have to add up all the spaces on the outside. So there's going to be a matching triangle on this side, but there's also going to be something there. There's going to be something chilling at the back there. Let me see if I can show you. So there's going to be stuff on the bottom, and there's going to be stuff. Oh, no, I don't know if I'm a very good artist. Let's see if I can try and do this. Oh, that wasn't too bad. Look at me, my art skills. All right. So there's a front triangle and a back triangle, but you've also got these other areas that you need to add up. See if you can find the surface area for this shape. So what are we going to get? So I'm going to go a half times 15 times, half times 18 times 15 for the front triangle, but there's a matching one on the back, so I'm going to go times 2 for that. What do I still need to find? I feel like Pythagoras is going to come back again. I feel like Pythagoras has to help me to figure out what the red length is. Can anyone tell me what the red length is using Pythagoras? So 23.43 is what we're getting for this. So now I have these rectangles. So there's going to be 23.43 times 14, which is really just this rectangle here. The rectangle at the back is going to be, let's see if I can show it to you. This seems like it's 14 times 15. Like it's that rectangle over there. And then the one on the bottom is going to be 18 times 14. And now I have to add up all of these. So help me in doing that. I get 1060.02 centimeters squared. Anybody else get that? Fantastic. All right. What I'm going to do now is I'm going to put the link to this week's quiz in the chat for you. And I'm going to let you actually go off and start this now. It shouldn't take you long. In fact, tonight's quiz is very, very short. So you can all just smash it, chop, chop. And then Sanako said, any tips for maths exams? All right. Sanako has asked a very, very good question. And I actually want to say, what would my strategy be for engaging with exams? So you know what I would do is all exams have this structure where 20% of it is going to be pure knowledge and about 30% or 35% is going to be simple procedures. Okay. Then after that, there's going to be another 30% for complex procedures. And then there's going to be 15% for problem solving. Now, the problem solving marks are always very hard to get. I would spend my time, if you're someone who finds maths relatively hard and you get a bit stressed in the exam, I would go with a green highlight at the beginning. And I would highlight all the questions that you think are either knowledge or simple procedure questions. I would then head my paper up so that 1.1, 1.2, 1.3, and maybe I decide that these two are the green ones. I would then just leave a big space for 1.3 that I can come back eventually. But I would start the exam by just going through and doing these ones. Because if you get these right, you will automatically get 55%. And they are the ones that you're most likely to get right. So that would be, Sanaka, I don't want to give too many tips on one day, but that for me would be a very, very good tip. So for example, like today, when we're doing this past exam paper question, I think that 8.1 was properly hard, but 8.2, I think everyone could have done if they had just gone straight to that and doing it. So it's this idea of taking a green highlighter and highlighting the stuff that looks appealing to you. Leave a space so that you don't want to change the order too much of your exam, but just leave a big space for that question that you can come back to. And that would be my one tip for today. Does that make sense, everyone? Give me a